Hello and welcome to this video on Cisco ACI Contracts. Contract is the fundamental security architecture in ACI that is used to permit the required traffic between EPGs. So that implies that, if you have only one EPG and the endpoints are residing inside of this EPG, they are free to communicate with each other. But if you have endpoints residing in different EPGs, then they're not free to communicate with each other. You as an admin have to go in and configure stuff, specifically contract, to allow communication between them. There are other ways also to allow communication between the EPGs for testing purposes, but eventually you will have to lock it down with a contract, the communication between the EPGs. So in Cisco ACI, there is actually no concept of source or destinations, okay, or the client or server. You as engineer may have that concept in your mind, same as I, but they use these terms, consumer EPG and provider EPG. So what that actually means is that providers are actually servers, which are providing the service. As you can see down here, I have one VM in VLAN 111 inside of an ESXi node that is on a specific subnet 10.1.111.10 that I have termed as provider. Now, why we call it the provider? Because it's providing services like SSH, HTTP, ICMP. You could call it a service, but yeah, we're calling it as a service. Normally, you would consider these two as services, but this is also a service that we need to open on the provider. And the consumer actually are the consumers of that service that is provided by the provider. So you could consider this as the client, and you could consider this as the server, or you could consider this as a source and this as the destination. But the Cisco ACI doesn't actually use those terms. They use a provider and consumer. Pretty simple, pretty neat concept of that. So we will have to apply the contract between them in order for this communication that we want to work. But before we even get to that, let me just clear this all, and let me just show you what we will do and introduce you to the lab. So as I said, we have this ESXi host running in our environment that are running two VMs only right now. Okay, VM1 and VM2. They're both separated in terms of VLAN and subnet. So the subnet on VLAN 111 is 10.1.111.0/24, and this is the IP address given to the VM1, which will be the provider or the server. And VLAN 112 will be the client VLAN, and the VM2 is running on it, so it will be 10.1.112.10. This is the IP address of this client machine. So what we will do is that we will take a look at the Cisco ACI logical model. If you've gone through my other videos, you know well that there are two models, logical and physical. The physical actually deals with what nodes are going to be participating and what are the interfaces and their policies and all. So that part has already been taken care of. What we will do is we will configure the logical part, the tenant, the VRF, the bridge domain, and all that. So what will happen in this lab, what we will do is that these guys will be sending packets out towards each other. They will obviously have default gateways, and they will be configured on the bridge domains over here. So I have separate bridge domains for them and for the understanding of this lab. So they will be communicating towards the ACI switch, and they will be tagging their traffic once they're exiting the ESXi host and going towards the ACI leaf. They will have their respective tags. For example, 112 VLAN tag will be coming in from VLAN 112, and we will configure the ACI leaf switch to actually recognize that tag and put that endpoint into EPG 112. Similar will be the case for VM1. It will come with VLAN 111 tag, and ACI switch will see that encapsulation and put it in EPG 111. Now both these EPGs need to be binded with a bridge domain. The bridge domain could have been the same, and truth be told, I was planning to like do this lab with only one bridge domain, but just for like simplicity's sake, I said, okay, well, let's make two bridge domains so that it is easy for you guys to understand. Regardless if it's a one bridge domain or two bridge domain, the thing is the endpoints are falling into different EPGs, right? So they can't actually communicate with each other until and unless we apply a contract or we tweak some parameters in the VRF to make them communicate, or put them in a specific group that I'll tell you once we have all this configuration set up. Okay, so the bridge domains are there, and both the bridge domains are part of the same VRF, and there will be a tenant as well, which I have not listed here actually. But let's go ahead and actually start configuring it, and on the fly I will guide you through what are all the parts of the contracts and what they actually do. So let's jump in. Okay, so this is the Cisco ACI's APIC. And this is the server VM1 that is residing in VLAN 111. This is a Linux box, and the client machine is basically a Windows box. Let me just log it in also. Okay, so we're going to be testing stuff from the client to the server once we have everything set up. So let's begin, huh? So let's just log into the APIC with our credentials. And the physical model, as I told you, I've already done. Let me just show you what the physical model is. This is the physical model, and in this we have done the switch profile part, in which we selected the leaf, which is leaf node is 101, and we have selected the port that is 1/9, and VLAN pools have been created, attached to a domain, to AAP, and the AAP is attached to the policy group already. And this part we haven't actually done. This tenant part we'll create right now. Create the tenant VRFs. Only one VRF is here, right? So okay, one VRF, two bridge domains, and each bridge domain will have the corresponding subnet. Then we'll create the application profile and the EPGs, and then eventually the contracts and all these subcomponents I'll go through and let you know what they are. So we go into tenants, and these are the three by default tenants. Let's create a new one. Let's create a tenant, and I'll say lab tenant. Okay, now the name of that tenant, just submit it. So now you're inside the tenant, and the first thing we will do, we'll create a VRF, and inside of it, it will also ask me to create one bridge domain, I think, or maybe I can create multiple, but let's just create the VRF first and just name it lab underscore VRF. So this will be the VRF name. Okay, what else do we need to do? We'll leave everything at default at right now. So click on next, and it's asking me to at least create one bridge domain. So we'll call this bridge domain BD for VLAN 111. Finish. Okay, so as you can see, the VRF has been created. The bridge domain has also been created. So let's create another bridge domain. We'll name it BD, bridge domain for VLAN 112. Okay, and we will associate it to this the same VRF, lab VRF. Okay, click on OK, and I don't know if you can view it properly. Okay, click on next and finish. Actually, I should not have finished this, but because I needed to assign subnets. So here is the lab that we were looking at. So first thing, we created the VRF. This is done. The bridge domains have been created, but we haven't created the subnets. So let's go ahead there and create the subnet. Hang on, what is this? Why they've been highlighted? Let me just refresh that. Maybe because of my pen that had been highlighted. So we go into the networking tab and bridge domains. So here you can see subnets. So from the lab, the first BD should have 10.1.111.254, right? So let's create that. Right click on it, create the subnet. This is basically the gateway. So 10.1.111.254/24. Okay, submit that. And for BD2, which is 112, I'll create the subnet with the corresponding 10.1.112.254/24. Okay, submit that. So that is done. Now what we need to do is we need to go into application profiles, because we needed to create EPGs. As per this model, you can see the application profile is there. That's mandatory. We need to create that and build the EPG and bind it to a bridge domain and to the domain as well. So let's go and create one application profile. So I'll just call it lab app profile. Okay, submit that. And let's create two EPGs here. Create application EPG. So I'll call it EPG VLAN 111. And the bridge domain association is over there, as you saw in that policy model. Bridge domain VLAN 111. And click on finish. Similarly, we'll create another one. As you can see over here, we got this EPG created. Let's create another one. Create EPG EPG VLAN 112. Okay, associating with its specific bridge domain. Okay, so click on finish. Okay, so that is done, but this is now sitting idle. It doesn't have any endpoints. No endpoints are registered in it. If you were to look at the VLAN 111 Linux server, let me just show you what the IP addresses are. ifconfig. So you can see the IP address of the Linux server is 10.1.111.10, and route -n. You can see what the gateway is configured. This is the gateway for this Linux, and it's the bridge domains IP. Right now, obviously, nothing you can do. You cannot ping it. If I were to try, obviously it wouldn't work, because I haven't actually made that port a trunk port and specified, okay, whenever you see VLAN 111, put it in EPG EPG-VLAN 111. So let's just do that first. And so the way to do that is via static bindings. But before we do that, go into domains and join the physical domain, because again, the policy models dictate you have to have that domain, and that domain's VLAN pool should have that VLAN pool which you're trying to tag here. Okay, so add the physical domain. It's already created by the name of physical_domain. So okay, so putting in that member. Now going towards the lab, we see it's a Ethernet 1/9. So okay, so static, not here actually. Yeah, static ports. Right click there, deploy static EPG. So you click on the node. Which node is it? You have to find it. So my node is 101, and the port is Ethernet 1/9. Okay, and the VLAN tag I'll be looking for is 111, and deployment to immediate. Port mode is trunk. Okay, so it'll look at encapsulations. So okay, so now if we were to look at this, I think it should be able to ping it. Yeah, sure enough it can ping it, starting ping. And similarly, what we will do is we will do the same thing for VLAN 112 over here, EPG VLAN 112. So I'll just bind the static port, deploy, and node 101, Ethernet, okay, what is it, 1/9, 112 is the VLAN tag that we'll see, mode is trunk. Okay, So we just hit the ping command on this VLAN Linux server. Let me just show you where does it actually show that the endpoint is residing inside this EPG now. So if you go to the EPG and the operational status, you can see that this is actually the endpoint that we all talk about. So the MAC address and IP address are being learned. By the way, if your gateway is not on the ACI, it's somewhere else, it won't specify the IP address, it will just specify the MAC address, okay? Just to put it out there. So this one I haven't joined the domain, so let me just join the domain as well. Okay. So now let me just hop onto the client PC and trying to ping his default gateway, and 1.112.254, I believe, yeah. Let me check if it's working or not. One timeout. Okay, great. So now it's pinging. So both are pinging their gateways. So if we were to see the topology right now, so we can see this VM1 can actually go, and it's inside this EPG, so it can ping its BD's IP address. And similar is the case for this guy. It's in VLAN 112, and it can ping its default gateway. Now, what else? Let me just show you the operational state and show you that endpoint has been learned. So here it is. The endpoint has been learned. So before even going to the contracts, if you want to actually verify that your server is indeed reachable by the client and the services that it's offering, can they be used? Like, can the client actually SSH to the server or not before you apply the contracts and all? Or you want to see the pings and all that stuff. So basically a permit IP, any kind of a scenario, if you want that, then you can actually do that as well. There are two ways. So let me show you the first way. If you were to go to the VRF, which has both these BDs, you can actually go here on the VRF and to policies, and this policy control enforcement preference. This is basically enforcing the policy to be applied before they communicate. So if you do it to just click it to unenforced and then apply it, what will happen, they will be able to communicate with each other now. So if I try to ping 10.1.111.10, as you can see, it's pinging, okay? And let's just check out if the server is indeed SSH capable or not. 111.10. Sure enough, you can SSH to it. You've got the login screen. Not sure what the password is actually, I just forgot. Anyways, you can see the prompt. That means you can get there, and you can also HTTP to that Linux box, and you should see the welcome to Nginx. Okay, so both things are working now. So this is to verify, okay, that before even applying the contract, things were working. If your security policy permits, you can do that. The other way you can actually do that, let's just put it to enforced and click on submit. This is by far the most easier way, and it's very good for troubleshooting if you can. I mean, like if there's an issue, you can actually, for the timing, if somebody is on your shoulders, you need to allow communication at front, you can do that with this policy control enforcement preference, set to an enforced, and then you're good to go. Everything will be open for all the BDs, and obviously in turn the EPGs, because the BDs are connected to the EPG. So the other way you can actually do that is by saying, okay, we will put these EPGs in a specific group, which is called preferred group. So you can actually put, I mean, before putting this, actually, let me show you that the ping should be dropping now. So there's no communication between them. Okay, I didn't test from the Linux, but you know, I'll test it now. But now you can see the pings are no longer working. So you just go to the EPG. This is the other way. So you could put them in the preferred group member, include that, and submit changes, and put this EPG or the EPG which you want to communicate with, or put them in the preferred group. You can go to that EPG and put them in the preferred group. So policy in general, so you can go down here and say preferred group member include. Okay, now one might think that this will start the communication, but it actually doesn't. There's a global feature on a VRF for this that you need to enable again. You have to go to the VRF and drop it down, and you see EPG collection for VRF. In the previous versions, this preferred group member option was available inside this policy, and you would see that option here. But I think the latest versions don't put it here. They put it here in the EPG collection for VRF. So you just need to enable this and click on submit the changes, and the communication should start working. Okay, so that's pretty much it. I mean, like, but with this option, you are a little bit specific, to be honest, because you're selecting the EPGs. So it's not like that one option that you don't want to enforce anything all the EPGs in a VRF will have a permit IP any kind of contract. Not exactly contract. It'll be just like a permit any for everyone in residing inside that VRF. So 10.1.112.10. So as you can see, it can also ping it. So pings are working fine, everything's working fine. So I'll just disable this now, submit, and get those guys out of the preferred group, because this is not what we want. We want contracts to be applied between them. But this is a very good troubleshooting and yeah, basically troubleshooting way. Okay, exclude, permit, submit, EPG, policy, general, and prefer exclude. Okay. Okay, so if you've got this understanding now, if you want to enable communication for a specific amount of time, then you can do that. But eventually, you have to put in contracts. So these options will bypass all the contracts. Even if you have applied the contracts, they will bypass them. Okay, so let's move on towards building the contracts and applying them. Okay, so now moving on to the contracts, let's see how we actually configure the contracts and what are the contracts components. Now, just made a diagram of this, that the contracts actually contain subjects, only one subject per contract. And the subjects actually contain one or more filters, and the filter actually contains the filter entries. Now, to make it a little bit sense of what I'm trying to say here, most of you guys are coming from Cisco router or ASA or something of that sort background, and you know ACLs, right? So what I try to do is I wanted to make this kind of syntax for you to help you understand what I'm trying to say here. Okay, so the filter in itself is, you could say, if you're creating an ACL with object groups, so you could say that object group service contains all the ports and all IP ports, say PCP, UDP, and all ports. So if you were to create an object group service in an ASA, this syntax is actually from the ASA, and you give it a name like ICMP in this case. So that will be considered as a filter. So inside of that object group, whatever you match, you actually match, okay, service object ICMP. So that's considered a filter entry. Let's take the other example, object group service. And the name of that service is web services. So you can think of it like the filter's name. And the web services, you know, it can have many ports like 80, 443, some customized HTTP or HTTPS port you have at your environment. So it can have multiple entries. So you can consider them as a filter entry. Now then in the filter entry, there are some things that you can see, like what is the service, TCP, UDP, ICMP, IP, whatever the case may be. You see the source range, okay, and the destination port. What destination port are we gonna connect to? So as you can see, this is kind of like the matching mechanism, right? So this is exactly what we will do in Cisco ACI when it comes to a filter. We will have the filter with a name, and we will have the filter entries. This is what we will do in the Cisco ACI. Once we have that matching criteria set up, then we will create a contract that will have a subject. Now the subject has 4 major attributes, I would say, inside of it. So what are those attributes? The first of all, the subject is the one that is gonna say, okay, am I gonna permit or deny that filter? Okay, so you can see I'm kind of denying ICMP, and I'm permitting the web services. That is the biggest key feature for the subject is the permission, the permitting or denying of the filters. The other thing is the logging. So once you have that permit and deny statement set up for the filter, you can log it as well. Now you might be thinking, okay, where are the source and destination IP addresses? Well, actually in ACI, there are no source and destination IP addresses. Just like I mentioned, it's consumer and provider EPGs, and anyone inside of those EPGs will get the access to the other EPG. So I'll show you how to apply that as well. So, but you're getting the concept, right? That it has this feature to permit or deny and to log or not to log. The other 2 cool features are actually based on a fact that contracts are not stateful. To elaborate that a little bit, let me just go to the slide over here. And okay, so this is the slide. Let me just get my pen real quick. Let me just show you what I mean when contracts are by nature stateful. Oh, sorry, stateless. They're not stateful. Oh, sorry, they're stateless. They don't maintain a state. Okay, so what I mean by that is that you've all known firewalls, right? So firewall have this inspect feature or the stateful feature, in which if there's a client sitting behind it, this inside subnet, and it's going outside, and you have allowed that traffic to go outside, so it will maintain a state table in which it will see the return traffic coming in and allow that as well. So if it's going on source port, let's say 555 and destination port of 80, then it's coming back in with destination port of 555 and source port is 80, right? That's the return traffic coming in. Then the stateful firewall will recognize, okay, this is the packet we sent out, right? So it's coming back in, so it should be allowed because it maintains the state. But if we look at routers and we don't use the established keyword in an ACL, and let's say we have an ACL applied both ways, saying that, okay, deny, and this ACL, another ACL has been applied on the outside interface saying deny all. So deny all here, deny all here. And we need to allow something. What will we do? We actually create an entry above this deny all and say, okay, permit traffic going towards specific port or something like that. If that is the case, what will happen? Let's say, okay, so in this case, if the user is sitting here and it wants to go to a specific server on port 80, let's say, it'll go outside here, and the return traffic will be dropped here because you have a deny all here. Okay, so you will have to explicitly permit the traffic coming back in. Remember, we're not using established keyword. If you use the established keyword in an ACL, it will act as a stateful device as well. It will maintain the state table. But let's say they're not using that state established keyword. Okay, so you get the idea, right? So you have to apply it both ways. So you have to permit the traffic here and permit the traffic here. Make a ACL entry above the denial on both sides. So this is exactly the not the problem, I would say. This is the way contracts work. That they have a denial on EPGs, and the thing is, you have to apply. If you're applying something one side, you have to apply it the other side as well, and obviously you have to reverse the directions. So if you're saying that source port any, and destination port is 80, you're allowing that, then the opposite of that would be what? So you're going to say source 80 and destination port any should be allowed, right? This is how it will work. Otherwise, it cannot work. So you might be saying, okay, so this is a risk, man. I mean, this is not cool. So for that, ACI has a specific feature, not a feature, per filter line. They have option called Stateful. Now in the Stateful, what it does, let me just put that out there before you guys start to ask this question, that this is a security risk. Why would I do that? Well, first of all, it's a router, it's connecting towards internet and all those stuff, and that is in the data center. But not to spoof this kind of a behavior, what ACI has is a stateful checkbox in which it'll say, I will only accept packets that are acknowledged state. Okay, so that is the stateful feature. That way, it will never expect a SYN packet coming from the outside, right? That is also a feature in ACI. I'll just show you once we're configuring the filters to mitigate that spoofing attack if it was to come in your data center. I hope you understand that. Once we start configuring stuff, then you'll get a better idea. So let's just hop into the configuration part now. But before we dive into the configuration part, just forgot, what about the contract? So this is the subject. This is gonna be done by the subject. It's gonna reverse the traffic. It's gonna reverse the source ports and destination ports. But what about, hang on. What about the contract itself? Well, the contract is the one that is going to be applied on the EPGs itself. So how does it get applied? Let me just show you that as well. 1 second. So the contracts, not the right one. 1 second. Yeah. So the contracts actually gets applied from the provider always to the consumer. So let me just grab my pen a little bit over here and okay. So the contract that you will create once you have filters and subjects placed in, we will actually go and configure the contract saying, okay, the contract will be provided from the provider to the consumer EPG. And the consumer will look at it, okay, you're saying that I can actually access you on port 80, on SSH, and I can also do ICMP pings. Right, great. So it's always provided by the provider to the consumer EPG, okay? So this is the main concept that we will do. Just remember that direction is basically a little bit, I would say, inverted. This is where a lot of people have problems, that they say, okay, the contract is given, why is the contract being given by the provider? It should have been applied on the consumer directly, right? And on the provider itself, no. It's like opposite. The provider has to give the contract to the consumer, and the consumer will just open that and see all the filters and all, and then say, okay, this is what I am permitted to do. I mean, to communicate with the provider. Okay, I hope you have got this concept, because it's a little bit twisted, but let us just go through the lab and you'll see that it's not that bad. Okay, so now finally we're going into the configuration part of the contract. So let's go to our topology, and we know exactly that this is the consumer and these are the ports I need to communicate to. So first off, let's create the filter. I'm going to be configuring it from bottom to up, okay? So the first thing I'm gonna do is gonna create, oh, not here. Oh, sorry. Not here as well. Contracts. First, we'll create a filter. Now, there is no specific folder for subjects. They're basically nested inside the contract. So once you hit create a standard contract, you will see the subject there. So let's create the filter here. So let's create the filter, and this is the one filter we're creating. Let's say ICMP. Okay, so I'm going to create 3 filters just so you understand what the concept is. So this is the filter name, as we'll just go to my syntax over here. So this filter I am creating right now, this is the name only. Once I'm inside that, so now I'll create the entries. You can see these are the filter entries. So click on the plus icon and say what is the name of this entry. So I'll say ICMP, or let's say ping. Okay, what is the ether type? So pings are ether type IP, and the IP protocol is ICMP. And there is no option for stateful. This is the one I was talking about, that stateful net, because they don't have ACS. So there's no option for stateful. There's no option for source or destination port. You can't actually match on codes on the ACI, ICMP. So let's just leave it as B. So this one is only for matching fragments, not too interested in that one. Okay, let's create submit. Now you can see a filter has been created, and it's just like this filter. Not filter, this object group service with 1 entry, right? So we'll just create another one with the name web services. So this, okay, web services. Let's create another filter, a create filter. Let's name it the same, web underscore services, and plus. So let's first say HTTP. The protocol is IP because TCP is part of the IP protocol, and specify TCP over here. Now there's an option for the stateful. Now, to be honest, I have not actually clicked this option, but it is there for to stop the spoofing attacks, so that the provider will not be attempting to establish a session with the consumer via a SYN packet. You know what? I'll just enable this and see how it works. I mean, you can't actually see this. You have to craft a specific packet to do a spoofing attack. You have to do a lot of work for that. So I may not do that right now. So the source port or the range, if you leave it as B, then it's kind of like the any statement, okay? But the destination port, we definitely want that, and that should be destination port 80. And if there's only 1 port you are specifying, then you have to specify from and to range on both sides. Update. Okay, so that's pretty cool. So let's create another one for HTTP as well. Even though we don't have HTTPS, but still I'll create that just so you know how it's done. So ether type IP, protocol is again TCP. Let's mark it as true, stateful, and HTTPS. They also have this HTTPS. Some protocols actually give you names as well. So let's put a name over here. Update. So click on submit. Okay, so you got another filter now which says web services. So HTTPS and HTTP. Sorry, HTTPS and HTTP. So now let's create another filter. The last one we're creating is remote access, just like here, CLI access. So I'll just name it CLI access, CLI access, and the plus sign you create, and we'll only say SSH, okay? And IP, TCP again, and port is 22. Oops. Port print 2. Okay, update that and click on submit. Okay, click on submit. Okay, right, so we've got 3 filters right now. Now they're just sitting ducks right now, because if you look at this analogy, we have to call them into a subject actually. So how do we do that? Well, there is no specific folder, as I told you, for the subjects. So you just go into contract and standard and right click that and create contract. So I'll say contract lab contract. I'll say lab underscore contract will be the name. Scope means, I mean, where can this be applied on a full VRF basis, like any EPGs that are residing inside one VRF, or maybe you have multiple application profiles, so in that you have multiple EPGs, so maybe it may be applied on them only, or the tenant or the global part. So this is basically the scope of the contract. For us, let it be on the VRF. Okay, quality of service and target DSCP, we're not looking into that. So subjects, if you go into that, right, just hit the plus icon and create lab subject. I said subnets or subject, I'm not sure. Anyways, so subjects, the first major thing that it does, as I told you, that contracts are stateful, not, sorry, stateless. I will forget that. Stateless, there is no state for the contracts. So what the subject does is whatever you call into the filter part, which we will do right now, it applies it in both directions if you want to. There's a check mark actually. And by the way, this you cannot edit. If you have done this once, then you cannot, you have to delete the subject and recreate it. The filter ports you can do actually. You can reverse them. So the reverse filter ports are exactly what they mean. Like if you have a source port as any and destination port at 80, it will reverse those ports and apply it. Better to leave it as it be, because if you don't, then it's kind of like that router that will deny all traffic, so it won't work. Okay, so these things we're not meddling into right now. What we will meddle into is the filters. So right, just plus symbol on this filter, and it'll give you a drop down on the all filters that you have, and some common filters as well. So ICMP, they give you actually a filter for that by default. But for me, I'm saying, okay, I'll use my own filters in caps. So I'll say ICMP, and what are the directives? Now, this is the logging. Now, as you can see, there's logging none, means it won't log, or it will log and keep it. And enable policy compression, it will log, but it will not keep it in its TCAM. So it conserves some space in the nexus. Sorry, the ACI leaf switches. Okay, so let's put it to log. And we'll try to check those logs as well. Where is it? It's not. Sorry, I'll have to do it again, I think. So it's set to none. I'll just set it in log. Some reason it's not showing me, I don't know why. Maybe it has done it. Anyways, let's click on ICMP. And the action part that I told you about them, the subjects, that they have 2 options, obviously permit or deny. So in subjects you have both the options. Not in the filters, you have that option in the subject. So priority, we're not going for any quality of service, so that's not for us right now. So click on update. Yeah, so there it is, the log, it's showing me now. So one filter has been called, which has 1 filter entry. Let me call the other one, that is web services. And let's log it too. And okay. And permitted. Okay, update. And the third one is SSH. Let's not configure SSH for now. We'll put SSH later here, so that we'll see, okay, it is doing HTTP, but it's not doing SSH, and what we can do, how we can add filters on the fly in the subject. So clicking on OK and submit. Now the lab contract has been created, but as you can see, it's again sitting ducks. It's not being applied to any EPGs. Now, there are two ways to actually apply this contract. Either you can actually go to the EPGs and call it over there in the EPGs, or there's a geographical way, which I really like because it's pretty good. So you go into the application profiles and the application profile name, that is LAN app profile, and go to the topology. Now you well know which one of these are the provider and which one is the consumer. So the consumer of this contract is 112, right? The provider, which is providing the services, HTTP and SSH, is the server inside VLAN 111 EPG. So you can see all these items over here on the top. So the first one is a contract. So I told you that the contract is provided by the provider to the consumer. So you just click on this, drag it over here, and this is the provider, and the contract will be given by the provider to the consumer. And let go of your mouse cursor, and here you have the option to actually create a new contract and actually call in all the filters as well, you see. But there's no subject over here, so you don't have the option to amend the subject here. I don't know why that is, but this is what it is. I don't know why, but you can select the existing contract as well, as we just created the lab contract. So we'll just call that in. So select that option, lab contract, lab underscore contract. This was the name of my contract, and click on OK. Now, every single time I forget to click on submit here, and I hope I won't forget it. Now, if I go to this client machine, and I hope, okay, it's timed out. So let me just log in this guy. So if I want to ping 10.1.111.10, sure enough, it's not pinging right now. So, okay, so let's apply the contract. The contract has been applied, and there it is. Pings have started to work. Now in our contract, if you hover over this, you see that we have ICMP filter name and web services. That's the other filter name that is providing HTTP and HTTPS access. We will test that HTTP, but before we do that, I just want to show you how it got applied on the EPG itself. So if you go to EPG VLAN 111 and go to the contracts part, 111 is our server or the provider EPG, right? So as you can see, it is basically, if you hit on create over here, actually add provided contract, you can actually bind the contract from here as well. So this is the contract that we have just applied from the topology of the application profile. Same here. So this is the consumer, so you can see the consumed is the contract is consumed. Okay, it is the consumer of the contract. So here we go. So let's test HTTPS. This is from the previous test. Let me just put it in incognito and test it out. Private window. Okay. So as you can see, we can connect to the HTTP, but we won't be able to connect to SSH. We should not be able to connect to the SSH, right? Okay, so SSH is not working. So, okay. So now what we do is we go into the contract here in the subject, and we can actually add filters on the fly. So let's add that filter that we created, that was CLI access. So you have those options here as well. So log, enable, permit. So permitting that, I think it should, okay, it already timed out. Let me just hit restart session, and here it is. So you can actually see the login prompt coming in. So that's how you apply the contracts on Cisco ACI. One more thing before actually we wrap up this lab is that supposedly there's a server that we want that anyone from any EPG, maybe you have hundreds of EPGs, and you want to actually enable at least the ping on that provider EPG. So how do you do that? So let's just go to the application profiles and not here, the topology, and right click on this, and don't delete the contract. If you delete the contract, it will delete the whole contract. So this will be deleted. Okay, you just go ahead and say, okay, remove contract relationships to the EPG. That way it won't delete the contract itself. Otherwise it will delete the full contract and you won't be able to use it. You will have to recreate that contract. What happened? Sometimes it is a little bit buggy. Okay, I think, yeah. So it's done. So there's an option for any EPG over here, if you can see. I think it was called VZ-EPG or something like that before. Now it's just called any. So any EPG, you can select which VRF it's part of. So VRF, the lab VRF that we created, it should be part of that. So we will apply the same contract to this, same way we did. No, this is, which one is the provider? One second, this one is the provider. So the provider and all, you have to make sure, being an admin, you should know which EPG should be the provider. So it should be crystal clear to you actually which one will be providing the services. So click on the contract, provider gives it to the consumer. Okay, select let's select the existing contract and select on OK. Okay, so now it should still work. Let's do a duplicate session. Does it work? Oh, as always, I forget to apply. Yeah, so you need to apply that. Yeah, so there it is. Now, even though I haven't actually applied the contract directly to EPG VLAN 112, you can see it is the consumer of that provider. That is because I mapped it to the any EPG. Okay, one thing I just want to show you that even though we're testing everything from here, the ping packets they behave a little bit differently. They're applied both ways and they don't have any source and destination ports. So pings will also work from the provider to the consumer as well. So if we were to ping 10.1.112.10, that will also work, because how pings are, there are no source or destination ports, so they can't reverse them. They can the subject can only reverse the direction. So that is why pings will work both ways. This is one thing that I was thinking about, that why does this happen actually, but it's the nature of the ICMP that is allowing it to communicate between both from provider to consumer, consumer to provider as well. So I hope this has been informative for you, and I'd like to thank you for viewing.